right, day 2 of our challenge, okay? It's the Math Guy Steve. All right, so this is day 2 of our 40 days, 40 problems challenge, all right? Today I'll walk through the solutions for the Cal 1, C102, and for my Cal 2 problem, which is C202. So our first problem is we have to evaluate the limit as x approaches 0 of sine of 5x over x. So anytime we see a limit like this, we should definitely consider the fact that we know the limit as x approaches 0 of sine of u over u. That's the classic one that we know is just equal to 1. So right now we have sine of 5x over x. So there's actually two different approaches here, right? The first one here, I just want to rewrite it as the sine of u over u, try to make it look like that, right? So if I take that sine of 5x over x, and I want to write that as sine of u over u, or something similar to that, right? So if we multiply top and bottom by 5, we have 5 times the sine of 5x over 5x, then this part here becomes exactly what we're talking about, right? And so we know from our rules of limits that a constant can come out in front, so we get 5 times the limit as x approaches 0 of the sine of 5x over 5x. And so now as x approaches 0, then we know 5x of course approaches 0. So we know this part here becomes 1, right? And so we get 5 times 1, which would just equal 5. Now, second approach is actually use L'Hopital's rule, right? Which says, okay, first, if I plug in this limit into the function, this becomes the sine of 5 times 0 over 0, which is sine of 0 over 0. We know the sine of 0 is 0, and so this becomes 0 over 0, right? And so because of that, we end up with one of those indeterminate forms, specifically one of the ones that's a fraction already, right? So again, there's a bunch of indeterminate forms, right? There's 0 to the infinity, or infinity to the 0, or infinity to the infinity, or infinity over infinity, or 0 over infinity, or negative infinity over infinity. It's a bunch of different versions of an indeterminate form. Once it's in this fraction form, though, then we can use L'Hopital's rule, which says, and L'Hopital is a mathematician from a long time ago, which says I can take the derivative, once I get the fraction form, I can take the derivative of the numerator, derivative of the denominator, and it's the same limits, right? And so normally we represent that we're using L'Hopital's rule by over our equal sign, we put this L apostrophe H, so L'Hopital's, okay? Not Le Hospital, okay? L'Hopital. And so once I'm using L'Hopital's rule, then it says that's the limit as x approaches 0, but now I'm taking the derivative of the numerator, derivative of the denominator. So the derivative of this numerator, sine of 5x would be cosine of 5x, but then times the derivative of the inside, so times 5, okay? Divided by the derivative of the denominator with respect to x, of course, is 1. And so now this is our new limit, not no limit, that's New Orleans stuff. This is the limit as x approaches 0 of just 5 cosine of 5x. But now plugging in the 0 from there, we know the cos, so this becomes 5 cosine of 5 times 0, which is 5 times the cosine of 0. We know the cosine of 0 is 1. So this equals 5 times 1, which is just 5. Okay, so we get the same limits with either method, okay? That's our Cal 1 problem. Again, hopefully you stay for the entire 40 days, okay? And always remember, math is everywhere. Stick around for the Cal 2 problem if you want. So our Cal 2 problem here said evaluate the integral of 2x over x squared plus 1 dx. So our first attempt is always to try to look to see if there's a u sub, specifically if the du is in the problem, right? So like if I considered that u is the denominator, is du in the numerator still left over? Well, let's see. Okay, so let u be, other than a great mathematician, let u be x squared plus 1. Okay, then the du, is du sitting there? Well, the du would be 2x plus 0, so 2x dx. Well, that's already in the integrand. 2x dx is directly there. So we know this is a quick u sub type of problem, okay? So there's our sub bubble, our subble, right? And so our integral now becomes the integral of, well, our u is in the denominator, but the 2x dx is the du, so du over u. And now we integrate with respect to u. So we know this is, okay, the integral of 1 over u du, or du over u, is just the ln of the absolute value of that u. Now that we're done integrating, don't forget the plus c, the constant of integration. And then lastly, we do what's called back substituting. This question asked me about x stuff, not u stuff. I made that up, right? And so we back substitute to plug that u back into what we ended up with. So the ln of the absolute value of x squared plus 1 plus c. Now, it's important to note that if you don't put the absolute value bars for this one, it's okay because that inside part or that argument of the log is always going to be positive since we're squaring something and then adding 1 to it. So if you put parentheses, it's fine. But in general, we don't want to fall into that habit of not putting the absolute value. So make sure you put the absolute values just in case, okay? So that'll be our Instagram, the element of absolute value of x squared plus 1 plus c. So again, hopefully you're sticking around for those 40 days. Okay, this is day 2. Okay, we got 38 more left, but that's okay. All right, again, at the end of this, our whole goal is to be better at calculus before next semester. Always remember, math is everywhere. As my children would say, don't forget to like, subscribe, and comment.